Today we will talk about two very interesting phenomena. Have you heard about black holes and neutron stars? We need to recall some basics. Remember that atom is almost empty. An analogy about nucleus is fly in the cathedral. If an atom were expanded to the size of a cathedral, then nucleus would be only about the size of a fly. But a fly many thousands of times heavier than the cathedral. That is totally weird. And also recall how sun burns. Its gravity puts so much pressure that it is enough to crush the nucleus inside its core. Now let's discuss what is a neutron star. Have you heard about it? It is quite strange. It is so dense that its one spoon will weigh about 1 billion tons. Just to give you an idea, Burj Khalifa, the tallest human-made structure, is 500,000 tons. A single spoonful of a neutron star matter is equal to 2,000 times Burj Khalifa's weight. Can you imagine that? In size, a typical neutron star is only about 20 kilometers in radius. What do you think? How much gravitational force does it have? 10 times of Earth's gravity, 100 times, or 1,000 times of Earth's gravity? Gravity on a neutron star is 2 billion times stronger than gravity on Earth. Well, how a star so dense is formed? It is formed in a supernova explosion, an event that occurs upon the death of a star. At that instant, the gravity presses the material so hard that protons and electrons combine to make neutrons. So all that electron cloud which makes the emptiness in the matter is no longer there. Only the pure, dense matter is left in the form of neutrons. Now you can guess why we call it neutron star. Gravity on a neutron star is strong enough to bend even light or radiation. This phenomena is known as gravitational lensing. So that was a neutron star. But what is a black hole? If a neutron star shrinks even further below a size known as Schwarzschild radius, it would become so dense that even light cannot escape its immense gravitational pull. We will call it a black hole. If an object reaches at the edge of a black hole, the event horizon, it will never come back. We can explain it in another way. If mass of an object exceeds a limit called the Chandrasekhar limit, named after a great Indian scientist, the object could no longer resist the force of gravity, and it would begin to collapse. Our Sun has a Schwarzschild radius of approximately 3 kilometers, whereas Earth is only about 9 millimeters. That means if we crush our Earth to the size of 9 millimeters, about a centimeter, it will turn into a black hole. Have you ever heard the story behind the name black hole? This is an interesting story. The phenomena was discovered by the physicist Schwarzschild in 1916. It was then known as the Schwarzschild radius. But the name black hole, very strangely, has a relation to Indian history. In the early 1960s, physicist Dr. Robert Dicke started using a simpler term. In the Dicke family, when something was lost, they all said it had been sucked into the black hole of Calcutta. Dicke, while talking about the intense gravitational force of a collapsed star, said it's like being drawn into the black hole of Calcutta. But the name wasn't universally taken up until 1967, and the term black hole was actually popularized by the physicist John Wheeler. That was it. Thank you. See you next time.